So we studied about principle of levers, that is, in equilibrium clockwise moment is equal to anti-clockwise moment. Now this is the sum given. The triangle is nothing but the fulcrum. On LHS you have 10 Newton which is at 6 meter from the fulcrum, and RHS you have 30 Newton, its distance is d from the fulcrum. They have asked you to find the value of d. So what are the steps? We will find what are the forces that will give rise to clockwise and anti-clockwise moment. So with respect to fulcrum, that is the triangle, 30 will go down, so it will make a clockwise moment, and 10 will go anti-clockwise, so it will give rise to anti-clockwise moment. So we identified the force which is clockwise and anti-clockwise moment. Now let us find the moment of it. So the formula for clockwise moment, for any moment in that case, it is force into perpendicular distance. I repeat, the distance is always from the fulcrum. So clockwise it is force, that is 30 into distance is d. So I got 30 d Newton meter, and anti-clockwise I got 10 into 6, that is 60 Nm. Now equate this clockwise and anti-clockwise moment. So I get 30d is equal to 60. 30d is 60, so d will be 60 divided by 30. Answer will be 2. So the answer is 2 meters. So the value of d, 2 meters. Clear? Here it's very important to note that the unit of force will be in Newton and the distance will be in meters, and the distance of any force will be from the fulcrum. Even the direction, if you want to know, it will be from the fulcrum. Let us take example from the textbook itself. I will read the first question. A nut can be opened by a lever of length 20 centimeter if minimum force required is 4 Newton. Calculate the moment of force to turn the nut. What is given? A nut can be opened by a lever of length 20 centimeter. So this 20 centimeter is nothing but the distance. So d will be 20 centimeter. If the minimum force required, force given is 4 Newton. You need to find the moment of force. So moment of force, the formula is F into D. Now if the force is 4 Newton, distance has to be in meters, but here it is in centimeter. So you will divide. How to divide centimeter to meter? Remember, you have to divide by 100. So 20 divided by 100. Or you can if you want, you can just do it here, divide by 100, you will get 0.2. So I am dividing here, 0, 0 cut. Okay. Then I will get 8 by 10, that is 0.8. Unit will be Newton meter. So I got the answer as 0.8 Newton meter. You can please copy this. Next, a moment of force of 10 Newton about point P is 50 Newton meter. Calculate the distance of point of application of force from that point. The moment of force of 10 Newton. Now this 10 Newton, I am doing the second one, okay. 10 Newton is the force. From the unit you will come to know it is 10 Newton. Moment of force. So moment, there is no short form of moment. So the moment of force given is 50 Newton meter. You need to find the distance. Again the same formula. Moment of force formula is F into D. Now this is 50. Force is 10 into D. Now I need D, so 10 will go below. So I will get D as 50 by 10, 0, 0 cut. I got 5. What is unit of distance? It is meter. So I will get 5 meter. Clear? Please copy this. Please don't forget to write the unit. Third sum. Two forces of magnitudes 25 Newton each acts vertically upwards and downwards on two ends of a rod having length 1 meter, freely pivoted at its midpoint. Determine the resultant moment of force about the midpoint of the rod. Two forces of magnitude 25 Newton each. Means there are two forces. Magnitude means value of 25 Newton each. Acts vertically upward and downward on two ends of a rod. So there is a rod. Okay, this is the rod. There is a force at two ends. One is upward, second one is downward. Both are 25 Newton. This is also 25 Newton. Okay. The overall length is 1 meter. It is 1 meter. Pivoted at its midpoint. So the fulcrum is at the center. So this distance will be half. This distance will be half. So it will be, I can say 0.5 meter. Even this is 0.5 meter. Okay, so first please draw the diagram. You need to find the resultant moment of force. Now with respect to fulcrum, this is going this way. That is what, just like a clock. So this is clockwise moment. With respect to fulcrum, even this is going this way. So both are clockwise moment. If both are same direction, you will add. Okay. So you got the answer that you need to add it. Okay. So first I will find moment of force for this, then this, and then we will add. So moment of force for first. It will be force into displacement or the distance. So 25 into 0.5. 25 into 0.5 is, it will be 12.5. Unit will be Nm. Similarly, even this 25 into 0.5, it will be 12.5 Newton meter. I said you need to add both. So when you add both, you will get, this will be 0, this will be 25 dot. So final answer I will get is 25 Newton meter. Got it? So please pause the video and you can just copy this. Next sum. The main gate of a building is 2.6 meter broad. Fine. So this is, we will draw a main gate. Fine. This is a main gate. Here gate means you will get what? You will get hinges. Here will be the hinge and here will be the handle. This is the hinge. It can be opened. So it is 2.6 broad. Fine. So this is 2.6 meter broad. Excuse me. It can be opened by applying 80 Newton at its midpoint. Center I am applying the force of 80 Newton. Hole is 2.6. The center, this distance will be half, midpoint. So it will be 1.3 meter. Clear? Calculate the least force which can open the gate. Where should the force be applied? Now this is very tricky question. Because I am applying force at the center. So at center it is 80. You need to find the force which I have to apply, that is the least force, in order to open this. Now you know where should I apply the least force? The least force will be applied here. Hence the handle is always away from the fulcrum. Because we studied that two ways in which we can increase the moment of force. Either increase the force or increase the perpendicular distance. Okay. In short, at center I am applying 80. What should I apply here? So see the formula, I am going to use it. See here. Okay. So F1, I will apply that equilibrium formula. F1 D1 will be equal to F2 D2. I applied 80 at 1.3. What force should I apply if it is 2.6? I need F. 2.6 will go niche. When I divide this 1.3 and this, I will get 2. 80 by 2 is 40. So the unit of this is 40, okay? It is Newton. So I got the answer, F is equal to 40 Newton. Clear? And the question is, where should you apply the force? The force should be applied at the farthest point, at the farthest end from the fulcrum. Clear? Next, a diagram is given. Calculate the unknown distance in the figure shown below. So there are two people here, say father and son. His mass is 50 kg. His mass is 25 kg. This distance is 2. You need to find this distance. I will use the formula of equilibrium, which is, so as per this, according to the fulcrum, this is going, he is going this way, so he is clockwise and he is anti-clockwise. I know that clockwise is equal to anti-clockwise. So 50 into distance is 2 should be equal to 25 into x. I need x, 25 will go downwards. So it will be 50 into 2 upon 25. Cut 2's are 2's are 4. Don't forget to write the unit. It is 4 meter. So the person, that is the son, should sit at the distance 4 meter from the fulcrum. Okay. So you can just copy this. You can pause the video and you can just copy this. Last, what is the moment of force about the pivot in the figure given below? So here is the pivot. This distance given is 3 meter. It is not printed properly. And this is 5 Newton. You need to find the moment of force. What is the formula? F into D. Very easy sum. 3 into 5 or 5 into 3, whatever. It's 15 Newton meter. Please also write the direction. According to the fulcrum, this will go this way. So it is what? Which direction? It is nothing but it is clockwise. So 15 Newton meter, N capital, M small, clockwise. Okay. With this, we end the chapter, third chapter, that is the turning effect of force. Thank you.